Good evening, everyone. Welcome to today's class. Our topic for today is network security fundamentals. The subtopics we're going to be looking at today on this model is what a network is, IP addresses, ports and port numbers, the OSI model, TCP and UDP, how the difference between TCP and UDP, then an introduction to basic networking tools. So the network consists of two or more computers that are linked in order to share resources such as printers, CDs, exchange files, or allow electronic communications. The computer on a network may be linked through cables, telephone lines, radio waves, satellite, or infrared. There are two basic types of networks, which are the local area network and the wide area network. So, speaking about network security is the protection of these underlying network infrastructures. That's the protection of the network infrastructures from unauthorized access, misuse, or theft. It involves creating secure infrastructure for devices, applications, users, and applications to work in a secure manner. So, what are IP addresses? An IP address is a numeric address. An IP address is a unique identifier that is assigned to every device connected to a computer network. Like example of these devices are our phones, our laptops. Most IoT devices have IP addresses like the smart door locks, the CCTV cameras, all have IP addresses. So IP addresses are used to identify and locate devices on the network and to route traffic between them. IP addresses are binary numbers, but they are usually displayed in a more readable format known as dotted decimal notation. In this format, an IP address is represented as four decimal numbers, each ranging from 0 to 225, separated by periods. For example, the IP address 192.168.1.1 is a private IP address that is commonly used for home networks. IP addresses are assigned to devices in one or two ways, statically or dynamically. A static IP address is a permanent address, that means it does not change, that is assigned to a device by an administrator. While a dynamic IP address is assigned by a dynamic host, that's a dynamic IP address is assigned by a dynamic host server, which allocates IP addresses from a pool of available addresses. There are two kinds of IP addresses. We have the IPv4 and IPv6. The IPv4 is limited, while the IPv6 address is unlimited. This is an example of a common home network. We have the router and different devices connected to it. So this is the network address, and the last two numbers here is the host. So moving forward to the next slide, we'll be talking about subnet mask. Subnet mask is a 32-bit number that is used in conjunction with an IP address to determine which part of the IP address identifies the network and which part identifies the host. It is a binary number that is represented in the same dotted decimal format as an IP address and is used to divide an IP address into a network prefix and a host identifier. The subnet mask is used to determine whether an IP address is located on the same network or on a different network. If the destination IP address is on the same network, the device can send the message directly to the destination. If the destination IP address is on a different network, the device must send the message to a router, which will then forward the message to the destination network. So, for example, if we consider an IP address to be 192.168.1.10 and a subnet mask of 225, subnet mask usually has 225.225.225.0. When the subnet mask is applied to the IP address, it breaks the IP address into two parts, the network and the host identifier. Let's say 192.168.1.0 is the network address. Like we talked about earlier, let's say that is the router. And the host identifier, the host is our device, which is 10. It means that all devices with an IP address in the range of 192.168.1.0 to 192.168.1.255 are on the same network. So the subnet mask divides the host from the network from the host. 192.168.1 is the network, then .255 is the host. Okay, any number ranging from .0 to 255 is the host, and they're on the same network. If you have questions about this, please contact me and I'll explain further. So the next subtopic we'll be looking at is the port. Port is a logical entity that identifies a specific process or service on a computer or device that is connected to a network. It is a number that is used to identify a specific application or service that is running on a device. When a device is connected to a network, it has an IP address that identifies the device on the network. When a client device wants to communicate with a specific application or service on that device, it sends a message to the device's IP address and specifies the port number of the application or service that it wants to communicate with. Port numbers are typically numbered from 0 to 65535, and different applications and services are assigned different port numbers. For example, HTTP typically uses port 80, while HTTPS uses port 443. So I forgot to put this on my slide, but um, register there are two different kinds of ports. There are a number of common network ports that are used frequently. Port 0 to 1023 are defined as well-known ports. So there are also registered ports. Registered ports ranges from 1024 to 49,151. The remainder of the ports from 49,152 to 65535 can be used dynamically by applications. So ports 0 to 1023 are well-known ports. They are normal ports like port 80, port 443, port 20, the FTP ports, the telnet ports are well-known ports. So the registered ports ranges from 1024 to 49,151. The remaining ports ranging from 49,152 So 65535 are used as are used dynamically by applications, like different applications. So moving forward, ports can also be used for network administration and security. For example, network administrators may use port scanning to identify which ports are open on a device, which can help them to identify potential security vulnerabilities. Firewalls and other security measures can be used to block or allow traffic to specific ports, which can help to protect devices from unauthorized access or malicious traffic. Okay, Mr. Boniface is going to take the Nmap, would teach you how to scan for open ports. Like in a network, if a particular port, let's say port 8080 is open, you can use that to exploit um, a particular website. Let's say you can use open ports to exploit websites. Mr. Boniface will throw more light on this. So we have a class activity. This will be done on our live class. We'll show you how to use what the Netstat is used for. So IP addresses is like a street name, while the ports is the house number of um um so everyone, the difference between an IP address and the port is the IP address acts like the street name and the location, while the port number is your house number. If a computer needs to communicate, it does not only need an IP address, it needs an IP address to locate the street name, let's say the street name, then the port number is the house number. These are different port numbers we have. They are like I talked about earlier. Some of the port numbers are port 20, port 21. Port 20 is the file transfer protocol. We have port 80, and also port 443. I think you should research more so you know the different port numbers we have. The next topic we're going to look at is the OSI model. The OSI model describes how a data is transferred over the network from one computer to the other, and the way the system sends information to one another. In order to accomplish a stable communication between computers, there are 7 distinctive layers which are connected to make this communication happen easier. These layers are layer 1, which is the physical layer. Layer 2 is the data link. Layer 3 is the network. Layer 4 is the transport. Layer 5 the session. Layer 6 the presentation, and layer 7 the application. um I have a way I remember this OSI model easily. I remember it as: please do not throw sausage pizza away. Like, it will help you. The physical layer is please. The data layer is do not. The layer 3, the network layer, is okay, do not. The N, not. The T is true. The S, sausage. The P, pizza. The layer 7, it's away. So don't forget it. Please do not throw sausage pizza away. In class, when we're having our live sessions, we'll try to rehearse this so that every one of us would be able to understand the OSI model. So the function of this OSI model is to enable functionality and operability between different vendors and connectors. So explaining the OSI model further, is when someone sends you an email, it goes to the presentation layer through the application layer and is being compressed. Then the next is sent to the section layer, which initializes communication and segments it in the transport layer. The network layer breaks it down to packets. It turns to frames on the data link layer. It will now be sent to the physical layer, where it is converted to zeros and ones and sent through a physical medium like the cables, the sockets and all. When the recipient gets the email through the physical medium, the the process starts again, but in the opposite direction. The opposite direction I mean is it starts from the physical layer, data link, network, transport, session, presentation, then the application. So that's how the OSI model work. Another communication protocol we have is the TCP UDP. The International Organization for Standardization created a conceptual model to allow different communication systems to talk using a standard protocol. That model is called the Open System Interconnection Model. Think of OSI as a universal language that lets computers of all kinds swap information. OSI has 7 layers, we talked about it earlier, and each of them serves as a guide for how information is exchanged. The TCP UDP are internet protocols that exist in the network layer. Internet protocols let you send emails to friends, download cat videos, or check your bank balance online. So in we'll consider IPs, the TCP IPs as the FedEx or UPS. You know what the FedEx, like the DHL, you know what they do. Somebody sends you a message, sends you a package from Netherlands, and you were able to receive it in Nigeria. That's what the TCP protocol does, delivering data packages to recipients. So what does TCP IP do? The main work of TCP is to transfer the data of a computer from one device to another. The main condition of this process is to make data reliable and accurate so that the receiver will receive the same information which is sent by the sender. To ensure that each reaches its final destination accurately, the TCP model divides its data into packets and combine them at the other end, which helps in maintaining the accuracy of the data while transferring from one end to another end. What is the difference between TCP and IP? TCP and IP are different protocols of computer networks. The basic difference between TCP is the transmission of data. In simple words, IP finds the destination of the mail and TCP has the work to send and receive the mail. So our next slide is how does the TCP model work? Hold on, did I? Okay. Whenever we send something over the internet using the TCP IP model, the TCP IP model divides the data into packets at the sender's end, and the same packets have to be recombined at the receiver's end to form the same data. And these things happen to maintain the accuracy of the data. TCP IP model divides the data into different layers where the data first go into this layer in one order and again in reverse order to get organized in the same way as at the receiver's end. So we have 5 layers of the TCP model, which is the application layer, the transport layer, the network layer, the data link layer, and physical layer. Okay, this is the 7 layers of the OSI model. On the TCP model, The application layer covers the application layer in the OSI model, the presentation layer, and the session layer. The transport layer still remains transport on the TCP IP model. The network layer still remains the network layer. Then the data link and physical layer is the covers the network access layer of the TCP IP model. UDPs stands for User Datagram Protocol. A more straightforward connectionless internet protocols that doesn't need error checking and recovery services. UDP has no overhead for opening, maintaining, or terminating connections. UDP continuously send data to to the recipient regardless of whether they get it or not. So moving forward, although UDP isn't the best choice for sending email, looking at a web page or downloading files is great for real-time communications such as broadcast or multitask network transmission. Our next slide, we're going to look at the difference between a UDP and TCP protocol. So the TCP protocol requires a handshake. The sender sends a message to the receiver, it synchronizes, then the receiver sends back a message to the sender, like saying ACK, then acknowledges the message. The UDP protocol doesn't require any acknowledgement, it just sends and receives responses automatically. So TCP communication indicates the order in which data packets should be received and confirm that packets arrive as intended. If a packet does not arrive, example due to congestion in intermediary networks, TCP requires that it be resent. UDP communication do not include any of this functionality. This difference creates some advantages because UDP does not require a handshake or check whether data arrives properly. Like I explained here, it is able to transfer data much faster than TCP because it doesn't need the receiver to acknowledge that it has received the message. It just sends request and responds automatically. However, this speed creates trade-off. If a UDP datagram is lost in transit, it will not be resent. As a result, applications that use UDP must be able to tolerate errors, loss, and duplication. So the last topic we're going to look at today is the networking tools. We have the ping tools, we have the netstart, we also have the trace route, and also some basic commands, which is who is and ns lookup, and also IP config commands, and if you want to IP config works with when you want to check the IP of your system on Windows, then the IF config works with the Linux OS if you want to check your IP on the Linux. So would look at this, would do this practically in our class on Saturday. Thank you so much, everyone. Please try and install your VM machine because we'll be using them for our weekend class. Install your VM machine, make sure your Kali Linux is working. Thank you so much, everyone. Enjoy your evening.